We have got time for questions. Once again, we will take questions from the audience, from Twitter, and from the webcast. And so with that, why don't we go to our first audience question. All right, we're going up to the top there.
Rick Weiss. I was working until a few months ago at DARPA, the Defense Department agency that funds a lot of this work. And I think to that agency's credit, most of the money, tens of millions of dollars that they put into this was not about how to do gene drives, but how to stop them and to come up with ways that you might be able to undo a gene drive, the Control-Z effort as it was known. And I wonder if anyone would like to speak to the possibility that one way to get around concerns, given the uncertainty of how things like this go, especially with fields of science that can self-propagate, perhaps a requirement that you be able to turn something off before you're allowed to turn something on. The analogy, by the way, that they went with was, why do you have brakes on your car? And it's not so you can stop, but it's so you can go fast, just knowing that you're able to stop.
Excellent question. So who wants to dive into that first, Fred?
Yeah, so this has been batted around a lot from the social side in terms of people's responses to that. The issue is if you release a gene drive and it's going out of control, researchers think they may be able to come up with a way of stopping it by inserting another gene drive that reverses it. And there's been mathematical models on this show that there are a couple little problems with it. But from the public's perspective, if you put a gene drive in and it's going out of control, and then you say, oh, but trust me, I'll get rid of it using another gene drive, that could be problematic. Now, there are other ways of doing that. Certainly, Jennifer Doudna and others are coming up with chemicals that might be able to be used to stop a gene drive. So I would say that that's a possibility, but perhaps the better way, and people are really in that safe gene thing from DARPA, are really researching ways to have these spatially limited drives or temporally limited drives that will go in and go out on their own, so that basically you could try it out, see if it works. So instead of going fast and then coming back, starting out slow, seeing how it performs, and then if it's better, going forward. And I would say Kevin's approach of doing this without gene drive at all is similar to what the malaria group from the Gates Foundation is doing in Africa, releasing something that doesn't have any gene drive first to see how it works. So both of those are possibilities.
And I have to say, I'm struck by the parallel here with the earlier discussion on artificial intelligence and robotics. And this is kind of another kind of an autonomous system that, you know, when it gets worried about it self-propagating and out of control. All right, let's take another audience question. We have one here in the front.
I have issues with gene drive as a geneticist in the suppression drives, because a lot we don't know about when you cause sterility in an animal, what genes are they choosing? And I have issues as what is being discussed about horizontal gene transfer and predator and prey of the species that are eating mosquitoes or mice that would take it, and maybe horizontal gene transfer might alter the sterility of an animal that eats, you know, whatever these species are.
Right, so I think this is, so I think this is the kind of thing where it really is, you know, where's the research community here? Why don't you know that already? And the thing is of course, if you looked at that, you know, 200-page or 300-page report by the National Academy, it discusses that stuff ad infinitum, right? It goes into all the detail of what would be the chance of that kind of horizontal gene transfer. The answer in the case of some species, like the mosquito that transmits dengue, is almost zero. In terms of Anopheles, the mosquito that transmits malaria, it's sort of a species swarm, so that it would transfer to other species in the Anopheles, but those are also ones that transmit malaria, not to the same extent as the main one. So we could talk more about that, but I would just say that, yeah, how can we get that information out in a better way? And maybe
so actually that was a good job. And you know, like I think the approach we took with the genetic engineering crop report was actually really good. Like in the one that it's an online report, searchable, where people have kind of specific question, can find the right section that answer exactly that point. And I think I'm turning to the National Academy of Science here, that, you know, I always said that the job starts once the consensus report is finished, because the goal is the people to actually use it. and that that's where communication should start and how it should be used in conversation. Because even among academics that are interested in the topic, they're not really aware and are able to access that, then we have a communication problem.
I actually was speaking to Kevin Esvelt earlier today, and he said the most frequent question that he gets from people on Nantucket and Martha's Vineyard is, what will happen if my pet cat eats one of the engineered mice?
Actually, so Pam, while you're speaking, I want to bring you back into the discussion with a question from the webcast. And so we're wondering how, what's the role of the media in terms of representing the more fence-sitting kinds of positions? How are you finding the reaction to these more polarizing positions, and you know, where are we going in terms of representing the mid positions?
Well, I mean, my approach is always to try to do my best to reflect the nuance and to not only say, as we've discussed, not what we don't know, but to also say when, you know, there's a variation among experts in the field. So if I were writing this type of story, that's what I would do. One approach that I take to try to get at that, to try to make sure that I'm kind of covering the waterfront, is when I'm interviewing a scientist about his or her work, I will frequently ask, who is your most credible critic, and what would they say? And they're always surprised by that question. I guess they don't get that question very often. But what I find is that the scientists I end up having the most respect for will answer that question. You know, they'll say, well, Fred, you know, does very good research. We come at this from a completely different way, and we have different conclusions. But if you go talk to him, he'll tell you this. And then the scientist might say, and this is how I would respond to that, which is just totally fine. That way I have the sense that I'm kind of getting, you know, the range of views from people who know what they're talking about.
Is there a right time to jump into the conversation from the media standpoint? So there's kind of a first paper, then, you know, there's a peer review, there's reactions, there's maybe a consensus paper. How do you think about where to jump in there, what's appropriate for the media?
When we actually write, you mean? That's a good question. I would say that we are very conscious in most cases, especially health and medical cases, which is the majority of the stuff that I write about. We're very conscious of writing too early. We're very careful about, for the most part, we don't write about things until they're at phase 3. We often don't write about things unless there have been several different takes on something. We really are careful and conscious of the risk of giving people either false hope or undue alarm. So we try to be careful. We have various ways of kind of coming to those conclusions, and sometimes those things can vary. So for example, if it's a very prominent researcher who is new to this particular field but has a name and credibility in some other field, we might say, okay, it's kind of news that they're writing about that, or that they're studying that. And so that might influence our news judgment. If it is actually an issue that is in the news for some reason, and we feel like this is a way to talk about it, we may write about it then. And we always try to sort of say, okay, well, this is where it is. In this field, it's not over here. You know, it hasn't reached this point yet.
Thank you. Let's take another question from the audience, all the way up top.
Thank you for your remarks. My name is Mona Bell. I work with NOAA's Sea Grant program in Georgia. I had a question regarding the role of professional societies. This room has several different disciplines represented, not only scientists, but journalists. One discipline that is missing in this conversation is the legal profession, because they do act as gatekeepers of science. So my question to the panel is, what do you think is the role of professional societies in facilitating this exchange across disciplines and perhaps clarifying and helping communicate science better, and especially scientific uncertainty? Thanks.
I'll give a quick answer and just say I think that's so important. And actually, the National Academy was very good. Dominque and I were involved in the report on genetically engineered crops. And when after that report came out, the staff of the NRC pulled together 15 different societies to come to the National Academy and do a critique of that report. So in that way, we got perspectives from a lot of different sides, including legal sides. But
that's the example I was going to say. I think, like, you know, when you can have as many, you know, let's say credible and trustworthy organization having, you know, put a thorough and thoughtful look in something that everybody disagree about, I think that can only be beneficial.
Thank you. Let's take another from the audience. Okay, over here.
This example of gene drive is a very particular example where the interaction between scientists and public can go wrong, because there were many people who did not care about the consequences. Some of those people might be able to do gene drive, and some of those people might get convinced based on the news that scientists will never do anything about it. And they take it from there.
Well, I think you highlighted a very important point. It goes back to what I think everybody was saying, Pam, Fred, and myself in conclusion, is the importance of public engagement, you know, like, and when you think in terms of potentially the communities that may be impacted by a particular release, or beyond that, the stakeholders that have an interest in the gene drive issue, or beyond that, you know, public at large that needs to be part of the policy making process, we need to find ways to have mechanisms to engage at those levels. That's the only way to go forward.
Thank you. I actually have a scientific question for you, Fred.
All right.
I'm picking up on the.
Let's hope I can do that.
I'm picking up on the comment about the lateral gene transfer.
Yeah.
So when we're talking about a technology like this with such a broad ecosystem level implication, how well, when we talk about risk, how well can we model propagation effects, just to inform a discussion like this?
So this is very important, and again, it's this issue of how do we best communicate those kinds of things? You know, that uncertainty.
Yeah.
You saw that in that report about uncertainty, and you know, I don't think any of the scientists. I think actually, I want to say that within this field of gene drive, there's a different kind of sense in terms of the researchers than there has been in terms of the genetically engineered crops.
Right.
And I, just briefly, this is not science, okay? But if you think about business models, there has been a real business model for genetically engineering crops and selling them to people and having them buy them again and again. Think of what I showed you. You produce a small number of insects, you release them, and they go. You can't sell them again. Right? So there wasn't a business model. There's no companies really that are doing gene drive research. People are doing sterile insect technique, but not doing gene drive research, probably because there is no incentive. That's all public sector funded by government organizations or by the Gates Foundation right now. But to get at your question, you know, so all I'm saying is people are not as reluctant to get into the discussions of uncertainty. And people are not in as much of a rush to get these things out, except probably for the malaria issue, okay? And so the question of this lateral transfer, you know, one of the things that is useful to understand is that these gene drives are actually really fragile at this point. But one of the things is that what you discussed yesterday with Matt was about how these are guide RNAs that look for a specific sequence of DNA. And what everybody's been looking for are sequences that are very specific, either to an island population of mice or to a whole species of Anopheles. But the idea that it would go somewhere else, you have the ability to do genomics to see if there are any sequences in related organisms. So people are doing that work, but to say there's no uncertainty would be a ridiculous statement. Right? You have to sort of evaluate what that uncertainty is and whether people are willing to take a risk. So if you ask people in Africa, do you care if we actually have gene transfer and you kill off 3 species of mosquitoes that don't transmit malaria, but we get rid of malaria in Africa? Easy answer.
Yes. Thank you very much. I appreciate that. All right, now, the lady right here has been waiting for some time. Let's go there.
Thank you. Thanks very much. I've been working on the GE, genetically engineered crops issue, for quite a while, and I know this panel is very experienced in that. So I'm wondering, are there lessons learned from a science communication standpoint, best practices, things to avoid for those working not only in gene drives but in the gene editing as well? How can we avoid this slow motion train wreck that has been genetically engineered crops communication? Thank you.
Thank you. Dominique, you want to dive into that one?
The genetic engineered crops, I would say, and Fred really explained how it's very different from the gene drive context. I mean, the business model, the groups involved, very different, obviously, in genetic engineering, a lot of industry-related research, going on and so on. It was clear, though, if you assume that what you are thinking about is, let's say, the potential human health risk related to ingesting GE crops, that our report clearly concluded that at this time we don't have scientific evidence to say that it's, dangerous to eat GE crops, this is not to say that any food might not pose some food risk at some point, right? So we were very careful to put caveats. But if you think back of when it started and when they were used and introduced on the marketplace, there was no clear customer benefits for it. I mean, this was something that was really sold, let's say, as farmers' benefits or industry, potential benefits and so on. But from a consumer point of view, there was never something that say, hey, look, there's a GE in this packet of whatever, corn syrup, and therefore it's less likely that there were pesticides on the corn that that you're going to ingest because of that. This kind of thing. So there was really, I think, that the background of something that really had no potential benefits for the consumer. And I think this is something that's very important to think, that we were communicating in terms of risk at some point. It was never communication about potential benefits.
Thank you very much. We've got time for one more question. How about up front here?
Talk to us about the risks of weaponizing this technology.
All right, I guess I should start on that.
Please.
Yeah, okay.
The workshop?
Yeah. So we actually just came back from a workshop in Germany put on by international national societies. The National Academy of Science was part of that. The German National Academy of Sciences, the European National Academy of Science, to look at biosecurity with these things. And of course, that's probably why DARPA is so interested in this. Of course, a lot of the researchers' response to this was, are you kidding me? There's so many better ways of causing damage. But this was,
we disagree with that. Yeah.
But think about the fact that if I hate starlings, right? I can get rid of starlings. Not today, but maybe 10 years from now. If I want to cause havoc with American agriculture, I can genetically engineer a gene drive into certain weeds, not all of them, but certain weeds to become resistant to herbicides, right? And that would spread. And it's that these are things within feasibility. So I think that these are things that should be on the horizon. And I think that sometimes I make the analogy of when we first started the internet, nobody really started the internet. When we first started, we weren't thinking of all the hacking kinds of things that could happen. It wasn't feasible. So, and then we moved into this thing where all these new kinds of things could happen. So we should be thinking, and we should be thinking as a bigger public about what those things could be and dealing with them. Do you want to add?
No, I think you're right. I think, and the keys, and I think maybe the scientists that were at this workshop are not creative enough to think about potential catastrophic scenarios, but it is actually, I think, an ethical, important thing to think about, that we need to imagine the worst case scenario and potentially address them. And what you're talking about is something that definitely we have discussed. Yeah.
All right, let's thank our panel.